Hey everyone, Lazy Ben. So we're going to continue for a little bit more on physics. It's nearly done though. And then after that we're going to formalize this system in the engine. And by that I mean we're going to place it into the engine in a place where we can just call it whenever we need it. This is probably going to be an effect. So yesterday we managed to get rocks blasting apart, or some kind of prototype of it. They're just quads at the moment, but we'll put textures on them eventually. It looks quite cool, I think. Using the rigid body physics system that we ported over yesterday, and we've nearly finished that now. We just need to do a little bit more in simulate pair. Is it in simulate pair? In simulate pair internal. So it's like if it doesn't intersect, what do we do? Because it might intersect, it hasn't intersected this frame, and it might not intersect next frame, but it might have intersected in the middle of the two frames and we didn't actually catch it. So we can't, that will just result in items flying through other items when they should have collided. So we need to be able to predict when, if something is just about to intersect. So we'll do that next. Get on with that now. Okay, so this is the code from my old engine that I was porting over. So we just need to finish off a little bit. This. So we need this section. We need to implement this section. This is the last bit. Okay. So we need GJK get time of impact. And that forwards time a little bit to see if there is an impact. See if there is a collision going to happen. Okay, so we want GJK time of impact, which is a separation result and a T and a succeeded. Ooh, let's just check actually, did we ever use this succeeded? No, so let's take that away. And we're going to take that away. And that's basically all it is. Okay, so let's do standard optional GJK time of impact result get time of impact const rigid body A const rigid body B okay. And then in the internal simulate pair internal, here it is. So auto time of impact equals get time of impact AB. If we have a time of impact and time of impact dot t is less than this t, meaning we're not going to catch it in this step, and we're not going to catch it in the next step. We have to go auto pen equals EPA find penetration AB. If pen and pen dot pen depth is greater than 0, resolve collision AB pen it's basically just this whole thing again. And then we actually manually set intersects to true. Didn't quite intersect, it nearly intersected. All right. So I might just put in a separate I'll just say, yeah, I'll put in a separate what I was going to say is put in a separate evaluate. So what do we need? Yeah, we'll put in a separate evaluate function. Evaluate rigid body A, rigid body B, float T. And evaluate does this. All right. So that just becomes if intersects evaluate A, B, T, and then that becomes evaluate A, B, T. All right. Time of impact. Says it doesn't have a T. T is not a member of standard optional. It's because, there we go. Fix all these compiler errors up. Okay. So I'm just wondering if that T yeah, we need to keep it fixed. I was just wondering if this T needs to be that T. But I think it does need to be that T. We'll see anyway. So now we just need to implement get time of impact. Which is a bit of a beefy function. We got T1 and T2, which is 0 and 1. Interestingly, we've allowed the caller to supply these. So I think that's how far forward in time do we want to go? Yeah. Okay. Because what we're doing is simulating a few frames ahead all at once. Okay, find separation AB. So this is actually standard optional now. So if not separation, return result right there. Else result, we set it there. So okay. So we do pass a separation. If it doesn't succeed, we just say it doesn't succeed. Okay, so we won't. Yeah. Whoops. We want to keep distance epsilon. So we want to say result equals GJK time of impact result, and then we're just going to say result separation equals separation and return the result. So we need get swept radius. So PA is A dot, PB is B dot, and that's RV dot length. Let's check that length 2 is that might be length squared. No, that's proper length. So we need to get swept radius. We don't know about that. B. So what does copying a rigid body do? Oh, that's very cheap, that's fine. So that's rv.n. T2 is undefined, right? So I think what we're going to do is we're not going to supply it this time. I'm just going to look 1 second into the future, which is quite a long time, really. So we're just going to go result.reset there. So when all these result.succeeded is false, it's result.reset. And then we're doing one more fine separation for the copies. And there for the copies. If not separation, ooh. So they don't return the distance. Interesting. So, if not result, we populate the result anyway. So I think we do need a separating. Okay. We'll put succeeded back in. I'm gonna say it's true. by default. And then here we'll just say result just ban this bot. We'll say result succeeded is false in that situation. The rest of the time it succeeded. So we say if separation and separation succeeded equals false, or just not separation succeeded. Maybe not actually. I'll take that back. If not separation, if not separation, result.reset, return result. Return result. Okay. So it depends here whether we want to break out of it or we want to continue. Don't know. So I think possibly we do need this succeeded, because here we're still setting the result to be false, but we're passing in the distant, we're still passing in some stuff. Okay, so I'm gonna go back to doing this. Bool succeeded equals true. and then we're just going to go result succeeded is false. And then here we're going to say if separation and not separation succeeded. Succeeded, we do that. Okay, we'll keep that. So now we just need the swept radius bit. What does that look like? Time of impact. So it just draws a circle, I think, around. Yeah, it's like the maximum radius around. Okay, so we'll put that in. Oops. Geometry. Where do we put it? I could put it anywhere. Swept radius. What's this? Float min. Standard numeric limits. Float smallest. Or lowest, is it? Alright, so we're looking for all 4 points on a rectangle again. Okay. So top left, top right, top right, R dot bottom right, R dot bottom left, and that's array count points. So this is just sweeping through all the points and drawing a circle and looking for the radius of the circle. So that's points I. Well, for auto P in points. That's right, that's fine. So this is pr.length squared. So interesting, yeah, okay, so it is the length. We're just comparing all the squares of the length and then square rooting it at the end. Okay, so that is get swept radius. So that's geometry. right swept radius. So that's a.bounds, a.bounds.center, and that's b.bounds, b.bounds.center. See if that compiles. Absolutely not. So there's no such thing as I32 in this engine, it's S32. Angle is also called radians now. T. Okay. Let's build that first before we play it. Okay. So that should be it. Let's just step through and just see what happens. Let's build it. Build it first. Could be a bit of a long build because we did add something into the maths library. So the main thing that we changed, which might be a little sketchy, is this. We'll see. But if this works fine, it is going to be very difficult to test. I mean, we'll have to like try and zoom a particle into very fast into something very small and see if it goes through it. Maybe we do need to just make this always return rather than be optional. Because there's these things here where we still might need... because we still might need to use information in here when we get to this point now because of this line here. We'll see. Yeah, I think we will. We'll work on this. We'll work on fine separation. So let's have a look at fine separation. So if you look, the result succeeded might be false there. But we could have populated it with the distance and the normal and then decided that it's not succeeded. Okay. So we're going to make this always return. Whoops. And then we're going to say succeeded is false by default. Well, we are breaking out though. So we're breaking out of this loop. And if we didn't succeed, we're setting it. I wonder if that is actually fine. I think it's actually fine. Okay. Let's set up a test situation then. Let's fly a particle very quickly into something and see if it warps through it. It shouldn't warp through it. This time of impact thing should kick in. Well, let's first just run the simulation and see that it's not changed. Okay. Hopefully it looks the same. Oh, we broke it a lot. We broke it a lot. Ooh. Saying it intersects there as well. Yeah. So time of impact. Okay, so this situation. Okay. So result distance is quite a long way away. So let's just try and figure out that. So separation's not even set there. So if the separation didn't succeed, we do that. So we're resetting the separation. Clearly not working anymore. We might have to go back. slam the door there. To work out this. So I think we might need to have a quick look at this again. Alright, so let's just not make this optional. This is what's causing the problem, I think. Alright, so we go along. Let me just say result. So result now is a result dot all these can go away. So we say result.succeeded is false, return result there and there. There we say result.succeeded is true. And both of them, result.succeeded is true. And then we say if not result.succeeded, then we do that. All right. Let's see then. Let's just get the compilers out of the way for that. Succeeded. If not separation dot succeeded, so interestingly on time of impact we're setting it all the time, so we can do that. We should do that probably. And that can be bool succeeded is false. So finding the separation, and we're just going result.separation is separation. and then we say result.succeeded is false. And then here we're saying result.succeeded is true. So all these resets are result.succeeded is false. So time of impact dot succeeded and time of impact dot t is less than t. Yes. Find separation. Okay. So that goes here. Whoops. Okay. Let's try that. So that's doing the opposite effect, really. They're all falling through the ground. Okay. Let's just double check that this is completely right. Well, actually, before we do that, Let's not do this and check that it's still working. If 0. So that's totally fine. So it's this time of impact thing. Don't want to spend too long on it because I don't really need it at the moment. We're just putting it in for completeness, really. It is slightly different though. Rather than just calling evaluate. Let's go back to doing it this way. A, B. Let's just find separation. Oh. No, it is the same. It is the same. All right, let's just check that this is exactly right. So, where were we? So 439. Okay. So this in the old system is set to 1. So we'll set it back to 1. So we find the separation and we set it. Return false. Otherwise, we get the separation distance. So if the distance is less than the distance epsilon, it's intersected. So we don't need this else. So we're returning. Then we get the separation normal, and then we get swept radius. Top left, top right, bottom left, bottom right. So let's just check get swept radius of. That's the local center. Okay. That's wrong. Rotation point. So I think. Oops. We don't want to do that. So that's wrong. Fix that now. Again, we don't need this else. So we make copies, and this is where we're going on into the future. Find separation. If separation doesn't succeed, okay. So if this doesn't work, it probably means that the original implementation didn't work. Okay. Again, we just changed the maths library, so this might take a while, unfortunately. Yeah, I mean, we were definitely calculating the swept radius wrong. That might have been what was the problem, because that would definitely give incorrect results. The rest of it, like, obviously I haven't been through it all of the maths, but it looks the same. We shall see. If this doesn't work, we'll have to debug it even more, really. We'll have to set up a test case. You see this time of impact. And I wonder also if this shouldn't be the time of impact t. We evaluate it up to the time of impact. Maybe. Because if you evaluate it past the time of impact, it is gonna be going through the object. It is going to be tunneling through, which is not what we want. Anyway, we'll see. Wait for it to build. Link, come on. Visual Studio's having a problem where it sometimes takes a long time to link. I have to like stop the build and start again. There we go. Okay. See what happens. They're all falling through, so let's just go time of impact.t. And we'll see what happens there. Yeah, it's like actually having the opposite effect. You can see they're all actually tunneling through the ground. So let's draw the ground. There's the ground. So the time of impact is 0.05 seconds. I think what I might do is just, because this is not needed right now, I don't want to like worry about it too much because it's not needed, and then we'll revisit it if we ever need really high precision collision, rather than spend ages trying to debug it. So the separation distance, yeah. So let's just do that. We'll work on it for a little bit longer. It might be because we're constantly applying gravity as well. Maybe. T1, so where does T2 come from? So that's just how far we're sweeping into the future. So that should only be, so let's do fluid T, right? And that should be T. So we only want to sweep a certain amount into the future. Alright, so let's just go to one. Well, we'll debug it a bit more. We're going to go just to one particle. Let's say one particle. And then we're not going to add in that one. And then we're just going to test that particle with the ground. May as well get this working if we can. Where is this particle? We'll just make it big enough to see all the time. We won't set the angular velocity, we won't set the mass. Yeah, we'll just leave. We won't set any of these. So it's just going to be a particle straight up falling. Okay, there we go. You can see it falling down, it bounces up, bounces on it, and it falls through. Just make that a little bit easier to see. We'll just say the flow color is getting stuck in the ground, falling straight through the ground. Okay. So let's try this. So time of impact, it should be false. So only looking one step into the future now. All right. So it's saying it's gonna hit then. So let's be time of impact on T. So what's interesting is when we do get the time of impact, we're not using any of it. Which is interesting. We're just getting the time and the separation. So I wonder actually if we need to just do this. Let's try that. That seems good, except we didn't lose any energy. That might have been all it needed. We'll go back to the other, all the particles in a second and have a look. Okay, so let's go back to the state where we had all the particles. Okay. And what I really want to do is slam a particle into it at really high speed and see if it doesn't warp through. Yeah, that's good. Yeah, so I think the problem was it never works in the original code because we weren't actually passing in the input result. Like the separation that I calculated in the impact result. Anyway, we found that error. Alright, so let's just make a let's just stress this out. The height, we're going to make 0.001. 0. So like a centimeter. So some did fall through there. So let's extend t to be 1 second. So we're going to go all the way through. So the little ones seem to fall through. So where are we incrementing L? L0 plus equals dt. dt is 0. d over drel. So let's just do 100 iterations of this. You can see some are falling through. Some quite big ones are as well. Okay, so let's see if we can set up a situation again. One particle. Finked, hey, how's it going? Working on some physics stuff. Trying to stop particles sometimes falling through the floor. Like that. All right. So we need to set up a situation where it's always falling through the floor. So we'll just add a big force. Yeah, we'll just say the force, the force in the Y direction. Pancake feast, yeah, had pancakes for breakfast. I had one. Kiki had 4. Emily Watson, thank you for the follow. How's it going? If you've got any questions, just ask. Flo had 2. Yeah, thanks. No, it's all good. Yeah, I'm doing good, thank you. Just working on some physicsy stuff at the moment. Sometimes a particle, I've got this little particle that drops on this yellow line. Sometimes it falls through, so I'm just trying to sort that out. Oh, good. So I'll show you. I'm working on like a mining, gameplay mining thing. So you can like mine for rocks. I'm a game developer. So I'm working on some gameplay stuff. I'll just get it to a state where it runs. So yeah, I'm working on some gameplay stuff where the character can go and mine rocks. So there's no rock there, but I'm working on particularly like if you shoot a laser and then hang on. I just commented this stuff out because I was working on something, working on a bit of a bug. Let's see if I can get it to work. The game's hanging now. Can you tell me how I can find clients for web development? So the people that I know that have had successful careers in web development, I've tried to find clients in their hometown. So like shops and little companies that might want websites doing. So they've put like adverts in local magazines, or they've gone into shops with flyers or whatever, and they've managed to get a few websites that way. All right. Let's just go back. A web dev project. Maybe when the game's in a bit more of a finished state. Right now, there's no reason for me to have a website for it just yet. I would definitely get like a website portfolio out, you know. It's going to be 2 or 3 years before I need a website for the game, I don't think. Alright, I think it's because yeah, if you've got a link, I'll have a look at it, no problem. There we go. All right. So yeah, you're a miner. And you're blasting rocks apart. Yeah, no problem. I'll have a look after the stream. It's just Lazy Ben Games on Discord. If you add me, when the stream's finished, I'll check it out. Alright, so let's just set up a situation. Where we're very thin and we had one body. And we just want bodies index.force.y is minus 50, say. Alright, so this should go through it hopefully. Yeah. All the time. Not all the time, maybe a little bit higher force. Sometimes it catches it. So let's just try like 100. Okay, let's make it even. Let's make it small. So the width height, we're just going to say is 0.2. Professional digital artist. Yeah, I'll have a look at your portfolio, no problem. Yeah, I'll have a look at your work. Maybe even smaller than that, we'll say 0.05. Right, so it's tiny. So it's falling through sometimes. Let's give it a much bigger velocity. I'll try and get a situation where it falls through all the time. So it's falling through most of the time there. Yeah, no problem. Yeah, I'll give you some feedback. But yeah, if you're wanting to get web clients, your nearest town or city, start local. Because then you can see them face to face all the time. They're the individuals I know who've made a success of it. Alright, so it didn't fall through there. It's falling through most of the time. Okay, let's just go even bigger. No problem. Sometimes it is catching it. All right. So what we're going to do is we're just going to see if we get in here. Need to turn the timer off. Great, yeah. When I finish the stream, I'll go on Discord, yeah. I will kindly accept that, no problem. Okay, so we need to actually we need like a frame counter. Oh great, thanks. Yeah, I've just set it up. Okay, that's when it. Let's see. So it's not catching it. So it's at 1685. Okay, so it's when it doesn't happen, which is what you would expect. So the time of impact code is not quite catching it. So it's strange because we're setting D and then we're breaking out. This is like code doesn't really make a lot of sense. Let's just maybe it should be continue, because it doesn't make sense for us to be setting the D there and then breaking out of the loop. Let's try that. Yeah, no problem, Emily. I finished stream like about 3 o'clock GMT, so 4 hours time. I'll check it out then. So that's always failing. Okay. I might have to read up on this. So what's going on there? RV. So we're drawing a vector in velocities. And then we're projecting it onto the normal. And then we're adding the max. So that is like how far along. D over d rel. So maybe we'll say dt. You say L. L is G1. So dt, let's try and do this a different way. dt equals t2 t2 minus t1 divided by max iterations, and then we'll just add dt onto L, and then we don't need to check this anymore. So dt goes from 0 to L. L needs to go from, yeah, that's correct. So let's just get rid of all this stuff. We just say L plus equals dt. And we just say if separation dot succeeded, return a break. So we're making this super simple now. So I'm going to say I'm going to do 30. So this is iter count. While iter count minus minus is greater than 0. I'm just going to scan forward in time. Try that. Okay, so let's just check. So just finding the separation between A and B didn't work. So we'll go along. So let's go in here. So we're going to add the velocities, add the angular velocities, find the separations. Succeeded. Right. That's interesting. So it's the difference in velocities. So that's like if they're going the same velocity. A max. And they have opposite angular velocities. Okay, so let's just straight up get rid of this from now. come along, I'm going to do a bunch of iterations. So the separation distance is 2.4. So the separation distance we need the actual distance between the two. So it's A and B, closest point A, closest point B. That's the distance between the 2 points. And so they don't intersect. We know they don't intersect. Okay. I think I'm going to have to knock this on the head because I'm just going to spend ages debugging it otherwise. So what we're going to do is I want to move on to something else. So we're just going to go to do this is broken, fix me. And I think we'll move on because I'm going to spend all day just debugging this and that's not what I want to do. Okay. So let's put this back. To this situation now. Oh, let's deal with these compiler errors first. That goes there like that. Alright, so we're back to this situation now. So I'm just going to put this into an effect. Effect controller. Okay. Struct rocks breaking. Rock break effect. Alright, rock break effect. And we're going to have these. And we'll have just GJK. Well, we want an array of rigid bodies. And then we want an array of GJK. Thanks for the follow. Okay, no problem. Yeah, just Lazy Ben Games is the Discord. So GJKs. There you go, there's the Discord invite if you want to join my Discord server. Okay. Rock break effect. So let's implement all of these. Oops. So put game state over there for now. When we open, what do we want to do? So rock break effect, it needs at least a position for now. And we probably could set all this up in the constructor actually. So position, and then we want to set all the bodies up. So bodies dot in place, and the ground is just going to be minus int max or minus FLT max. The Y, no, it's going to be the Y is going to be position dot Y minus 1. The width is going to be FLT max, and the height is going to be minus FLT max. So auto ground bounds is that dot right in. So it's going to be right over to the left, and then at that Y position, the width is going to be infinite, the height is going to be infinitely down. So ground bounds, FLT max, so that's the ground, and then we'll just go body. Whoops. And then we're going to replace all the GJKs and then what we might do is we might actually set up an initial position as well. There needs to be an initial everything, so we're going to say initial bodies, and then this can be initial bodies. Initial bodies. And then we just want to go bodies dot copy from initial bodies. Initial bodies. Initial bodies. So on open, we'll just do that. We'll do bodies.empty. Copy everything. So this could be reserve bodies.account. So that resets the whole system. Right, let's check that builds. Okay. So we need to include rigid body and GJK. All right, good. So I might not make that, I might just make that very big. Okay, so on open that happens, and then on tick, so we have to say alpha is 0, and then let's say alpha is 1 for now. Then on tick, we need to go for auto B, well, for B1 bodies, auto body, equals bodies b body dot tick dt. Then we'll just draw it. We'll just draw it at 0.6 for now. An alpha of 0.6 for now. And then we need to do the simulate pair. So that simulates all of the bodies with the ground and draws them. And then what we also need to do is get the total energy. We just need to do energy plus equals body dot energy, and then we return that whether the energy is not equal to 0. Okay. Now in game state, what we want to do is get rid of all this. We're going to do get effects controller dot play effect canvas equals get game canvas, and the effect we want to be break effect position, which I'm going to say vec2 0 0. So if we press L, we play that effect. Let's see. Ground's in the wrong place for a start. So let's just draw the ground. Canvas, draw quad in world. Bodies 0 dot bounds. like no ground there at all. So let's do minus 10,000 and the ham 2. Oh yeah, I know why that's not working. There we go, let's try that. Not enough range. Still not seeing it. Okay, well, let's just do minus 10,000 up to 20,000. Put a breakpoint there and check. Oh. Ooh. So I'll say FLT max over 2 and say position Y minus 10,000, height 10,000. Right, let's try that. All right, minus 10,000, 20,000. We won't do right in. There we go. Okay. So say minus 3 plus 2. So they're not losing energy. It's because we need to say initial bodies 0, energy equals FLT max. So I think actually break apart effect did look quite nice, having a little collider. Okay. Well, we can just put it back in. So we have another one, like the spreader bounds, which is position.x, position.y minus 0.5 or minus 1. Spreader bounds, FLT max, pi over 4. That's 2. So let's draw also draw bodies 1, bodies 1 radians. Okay, so we want this to be minus FLT max over 2 FLT max, and that's to be minus 999, minus 10,000. 9999. Make the ground very large. That's not working, so alright, well, we'll just leave it what it was. It's fine. Let's put something jump in there. So it's no good saying the energy. We'll just say it happens over 10 seconds. Or something. So rather than alpha, we're going to have a T. And float T max. So 5 seconds for now. And we're just going to say T equals 0. And then we're going to go T plus equals dt, return T is less than T max. And that should make the effect disappear after 5 seconds. Okay, so let's not draw these. And we want them to fade out as well, really. Some of them are actually okay. Make the end velocity a little bit less intense, because that's quite intense. Quite strong. Let's say 35. Weird, man, because it's not looking as good. Right, let's just go back here. That was a thickness of 1. Alright, get this working, then I'm going to take a quick break for a minute. Couple of minute coffee break, I think. Yeah, not as good, is it? Not as good. Let's raise it a little bit higher up. I'll move the ground lower a bit. No, it's not right. Something's not right. Let's go back to how it was here. That's good, that's what I want. Okay. Alright, I'm going to take a quick break, get a cup of coffee, and then we'll fix it. Alright, recharge with coffee. So let's just copy all this over. Like this. And these are initial bodies. Initial bodies. So this position was not 10. So we probably want position.x, position.y minus 1. And then this is position.y plus 1. And this is position.y. Try that. This has to go back what it was. Okay, so we're inside there. So say -2. That can be position.y minus 1, and that can be position.y. Let's try that. Just about getting these in the right place, really. Once they're in the right place, it should be fine. There we go. Check that is 0, 0. Near enough 0, 0. Okay, so let's just spawn it where the player is at the moment. Let's spawn it where the cursor is. So cursor position is canvas.get cursor position in world. Just spawn it at the cursor position for now. And then once this is in, we can move on to actually the mining system, which is going to be good. So put the cursor here, so there. Interesting. So they're spreading them all along that line. Position.x, position.y. Ah, there you go. That's a bit of a bug. So let's just put these in for completeness. Alright, let's see how this looks. So we could probably narrow it, we could probably increase that range, at least in X. Maybe in Y as well. Very spinny as well. Let's just turn down the spinniness. Let's not divide it by mass. Okay. Set the mass to be the area. Let's see what happens there. Go everywhere. So they need to be a bit more massive. 10 times the bounds area. Okay. We need a little bit less force. Okay. So I think it has to be 1 plus. Let's try that. I think anything, if the mass gets below 1, weird things happen. Yeah, very spinny as well. Let's make them a lot less spinny. Okay. Make the gravity a lot stronger as well. I don't know about that really. Okay. Doesn't appear to be having much of an effect. bit less. That's kind of breaking apart. So let's shoot some of them up. So this has got to counteract gravity, of course, so it needs to be at least above 9.8, so say like 12. Let's disable VSync as well. It's fine with disabled VSync. Just check that that wasn't a thing. That was a problem. Interesting. So let's just do like 18. See if we can get some of them to go up into the air. And then we'll finish work on this effect and we'll move on to the mining. So it's pushing it, isn't it? Really. So I wonder, rather than that falls, is velocity. I wonder if we should set velocity. Quite good, except it's very, very over the top. Maybe a little bit less. Alright, how's it going?
Alright.
Yeah, you alright?
Somebody to see you.
Alright.
Hello there, how you doing?
Thank
You
you.
alright?
Yeah, I'm good, thank you.
You been well?
Yeah. Let's take a 2-minute break. Alright, I'm back. I think we'll just stick with that.
Can I have your sugar?
Yeah, I mean, we don't have any spots.
No.
Not sophisticated.
Maybe a little bit less. And then we'll move on. Let's set gravity on the individual particle, the individual body. So we're going to say float gravity is minus 9.8.